Now we will continue the second part. Find the area of the finite region bounded by the curve and the x-axis. As you can see, we have 2 points. The first part is above the x-axis, while the second part is below the x-axis. This is region 1 and this is region 2. We want to find the area of the shaded part, region 1 and region 2. The total area is area of region 1 plus area of region 2. We need to start with the area of region 1. Just like we did previously, it is integral of y dx, where x starts at -3 and ends at 0, while knowing that R1 is above the x-axis. Plus the area of region 2. Remember that here this region is below the x-axis, so the answer will be negative if we do the normal integration. That is why we need to put a minus sign before it. So minus integral y dx, where x starts at 0 and ends at 1. We put the minus in order to get a positive answer because the region is below the x-axis, which yields in a negative answer. Notice that in both parts of the formula we have integral y dx, and we have y as an expanded form. So instead of writing it twice for each part and doing the integration for each, we will do the integration once and then we will substitute. So, integral y dx, it is integral x cubed plus 2x squared minus 3x dx. Okay, x to the power 4 over 4 plus 2x to the power 3 over 3 minus 3. Since here the x is to the power 1, then the integration is x to the power 2 over 2. We will not add plus constant because we will directly use the definite integration. Okay, now we will substitute each value. The first one is integral y dx, where x starts at -3 and ends at 0. We open square brackets and we add the limits of x. And we write the answer of the integral y dx. So, x to the power 4 over 4 plus 2x to the power 3 over 3 minus 3x to the power 2 over 2. If we add the 0 to the first term, as you can see, we have x in all the terms, so the answer will be 0. Minus, we open a parenthesis in order to substitute the value -3. So, -3 raised to the power 4, it is 81 over 4, plus 2 and 2, -3 raised to the power 3 is -27 over 3, -3 into -3 squared, which is 9 over 2. 0 minus, that means we have minus. We will put 81 over 4. 2 times -27 is -54 over 3. -3 times 9, so -27 over 2. The common denominator here is 12. And we do the normal calculations. The final answer is 45 over 4. This is the answer of the first integral. So we have area of R1. Area R1 is 45 over 4. Okay, now we need area of R2, which we will multiply with a minus in order to be positive. Integral y dx starting from 0 to 1. At the end, we will multiply by the minus in order to get a positive answer. We have the square brackets, x to the power 4 over 4 plus 2x cubed over 3 minus 3x squared over 2, where x starts at 0 and ends at 1. We will start with the upper limit, which is 1. 1 over 4 plus 2 times 1 is 2 over 3 minus 1 squared is 1 times 3 is 3, so 3 over 2. Minus. The lower limit is 0. If we substitute the 0, the answer will be 0. So minus 0. Okay. Here we have 1 over 4 plus 2 over 3 minus 3 over 2. We will do the normal calculations and the final answer is minus 7 over 12. Now we multiply by the minus in order to get a positive answer. So the area of R2 is 7 over 12. Now we calculated each part separately and we need to add them together. So for the total area, it is going to be R1 plus R2. That means 45 over 4 plus 7 over 2. You can use the calculator to get the answer directly. It is 71 over 6, or the compound fraction, which is 11, 5 over 6. As a conclusion, this is how you work if the curve straddles the x-axis. You divide the area that you want to calculate into two parts. Region 1 is the one above, region 2 is the one below. Then you calculate the value of each one, and then you add them to get the total area. You can solve these exercises in the same way. The only difference is in the curves. It could be a quadratic function, so it is a parabola, which could be opened upward or downward. Or you could have a cubic function, which is the same as the one that we just solved. Pay attention to the sketch, it should be accurate, and you should calculate the x-axis and then you divide the regions in order to calculate them, and finally you add them together in order to get the total area.